welcome back to the training of the M172. Continue with the expansion module. We're gonna see now how to configure the PLC to communicate with the expansion module. So the first thing that you need to see is that we have different ways to communicate with the CAN. So for example, in this part, we're gonna see the master for field to communicate with the expansion modules, but we also have the possibility to communicate to other PLCs over CAN binding. So there is something that I didn't mention in the last part. That is how many modules we can connect to the PLC. If we go to the hardware manual, okay, expansion bus for field, we have maximum one PLC, which is this one in our case, the smaller one. And if we want to communicate to slaves, we have up to 12 expansion modules, okay? But there is this note, this number can be reduced depending on the number of inputs and outputs that the master can control, okay? So based on that, in the amount of slaves, there is also other thing that we need to take care is this is the hardware communication between the PLC and the modules. So for example, if the PLC ends with R, okay, it means that it's non-isolated power supply. So we should not connect the ground between the modules to the PLC. But if the PLC is isolated, which ends with I at the end, we should connect the ground to the expansion module. So let's go back to the presentation. Okay, so we have already defined the amount of slaves that we can connect to the PLC, and also the possibility for the CAN binding. But there is a good question here. Can we use the master binding in the same CAN port? No, we can't do that. In order to use the CAN binding and the CanMaster, we need to add this communication module for additional CAN expansion. Okay, so if we want to use the master to communicate to the slaves and the binding to communicate to another PLC using CAN, we need to add this reference in the part of plugin in our configuration. Okay, so now let's see how we can set up the expansion module. Okay, we first need to go to the PLC in the configuration, select expansion bus, and define as master for field, and then the configuration, okay, that we have here. Let me just do this in our software, and then we can proceed. Oops, there we go. So we need to go to the configuration, expansion, and select master. Then we have all these options available. So once we have configured this in the PLC side, okay, we should know the actual configuration in the module. So in the bottom part, we have these switches, 6 switches. So the first one is for the terminal resistors, and the number 2 and 3 belongs to the baud rate. So we're gonna select this one, okay. And then if we have the last 3, we have for the address. So I'm gonna leave just these 5 switches top, and this one we're gonna see later the status. Now we have configured the communication parameters for the expansion, okay, and then the configuration in the PLC side. Now we need to take care how is the connection between the PLC and the module. So in our case, we have this one, okay, with the smaller PLC, and I have communication between the PLC and the expansion module using these 2 cables with a different power supply of 24 DC. Okay, so now there are other ways to connect here that you can find this in the international training for this PLC. Okay, for more information about the different way to connect and also an instruction sheet for the expansion model. But in this case, we want to focus only on this one, that's the one that we have in our demo case. So now we need to define the variables that we're going to use in the expansion model. Okay, so in order to do that, we need to go to our software, IO mapping, and fill. So here, I'm going to define three variables. Okay, one for the analog input, proof, expansion, digital output, cooling, expansion, and digital output, alarm, expansion. Now we need to configure the type. This is integer, okay, analog, this boolean, and in is not input, it's output because our digital outputs. So we have defined this, but so far we haven't linked that to any of the specific IOs of the controller. So this is something good because we can define any field variable here without using it yet. Okay, and we don't have any problem. So now we have defined these three variables to be linked in the expansion model. Okay, now we need to duplicate some of these variables, okay, but regarding to um, the control that we're gonna use in the expansion model. So what we're gonna do is to duplicate these variables, okay, copy, paste, but to be used in the expansion. So expansion, 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 just changing the name, okay, expansion, there we go. Need to change this, expansion, minimum, check again here for the maximum. So we have defined these new variables, okay, for the expansion, recalc, there we go, good. Now the status one, I need to duplicate this, copy, paste, expansion, expansion, good. There is no overlap in here, which is good. So now what we need to do is to create another function block, another poll, okay, with the same values. But I can easily create a new one, okay, add new program and start doing the same, or I can just duplicate this and add expansion. Okay, as you can see, there is no call for this function block, so we need to call it manually. There we go. So now we need to change those variables, okay, because now it should be linked to the expansion module and not to the PLC. So if we go to, oops, aux global, share, IO mapping, we can see here the new variables. Input, delete this, new one. I need to change this for cooling. Which is also indication, but I'm gonna use it later. the analog. There we go. I have also add the status output. Delete this one, connect it here, and this one for alarm. There's the communication. Right click, connection mode, and it's connected. And finally, the EEPROM, the configuration. I have the hysteresis as input, and I have the set point as input. So I'm going to delete this variable and this one, connect it here, and connect it here. So now we have duplicate the function block, the function type program into to use to the expansion model, okay? And this one, copy and paste it here. If we need to change this, I just go to start and input. Good. So we have made the logic for the expansion, okay? But now we need to link and define the expansion in our program. So we need to go to configuration, expansion, right click, add. We need to add the expansion, which should be this one. Here we can define the node number, which should be linked to the address. Let me show you the part of the presentation. Here, the address. Let's go back to the software. There we go. So now we need to go to digital IO, define which expansion model do we have. We have the 12 or the 98, okay, 28. So we're going to define this one. That's the one that we have. And then I have defined two digital outputs. So I'm going to use this one. So and I need to assign a variable that I have created. So I'm going to use this one. And I'm going to use this one. Okay, those variables I created in the part here. Okay, simple as that. So now we need to configure the analog IO, the same 12. And now here I'm going to use only NTC, but I need to define this one, that one. There we go. I'm not going to use nothing here, not configure. So I have linked the variable font field to the expansion model. Okay, so we have linked the variables to the expansion. We have configured the expansion model physically, and we have configured the configuration for the PLC side. Okay, we have made the programming for that expansion model. Okay, so now we should download the program, okay, and verify that is everything working. Okay, now we're going to download to the PLC, okay, which is connected here, okay, over Ethernet. Let's check setup communication. This is the IP address I have. Okay, so now connect and let's proceed with a full download. So we have the possibility to download the new configuration for the hardware. Download all. Good. Okay, it's downloading. Okay. The device is already the target. Continue. Load in progress. Okay, we have a right then. Okay, yes. So let's check. Okay, gonna reboot now. Let's check. It's rebooting. See a firmware. Everything's okay. No plugin. There we go. We have a start. So now we need to connect to the controller. Okay. Different. Download. Okay, so this is equal. Now if we live this, you can see here that I'm connected to this PLC and I'm going to share the information. This proof should be increased, as you can see in there. It's good. So the communication is working. Now I'm gonna disconnect this, the CAN port. Okay, as you can see, there is no communication at all. Okay, so now the big question. How do we know if the communication is correctly or not? So in order to know that, okay, there are two structures, okay, two arrays, syscan open node status and sys peripheral status. So this one, okay, has this amount of information, okay, it's an array of unsigned single int, okay, and it can have these values, okay, this is the status for the CAN communication to that model. And then we have the peripheral status, if it's connected or not, basically, okay. So the number inside that structure is related to the address that we have here with the node name, the node number. So if the address in this equipment is 1, we should ask for the number 3. We need add 2 to this. So in this example, if the address is 3, the number that we take a look inside this array is the number 5. The same case, if I have the number 10, the number here is 12. So basically, if this element in this array is true, this means that everything is okay. Okay, it's not okay. Okay, sorry. True means that it's not okay. It's not recognized. And if it's false, it means that everything is all right. So what we need to do now is to make a POU program, okay, for diagnostic. So let's go to our program. Okay, I have the connection again to the controller. Okay, that's why I'm reading information. Now we're gonna disconnect. I'm gonna add new program, and I'm gonna use function block. Okay, PRG diag. I'm gonna call in time. Okay, everything new. So now we need to take a look in operators and blocks. Here, we need to check in target variables. The best way to do is by folder. Okay, we need to go to peripheral. You can see here the structure. Okay, I'm going to use, in this case, this one, peripheral status, as input. Here, we need to add the element that we want to read. So in this case it's number 3 because the address is the number 1, so we need to add 2. Okay. Now let's create the following logic. That's good. We want to use the local LEDs in front of the PLC. Okay, let me show you which ones. These ones, okay, to indicate that we have connection to the expansion model or not. So we're going to use these local LEDs, okay, and try to replicate this logic. So let's go back to our program and create that logic. So first we need these LEDs. They are in LEDs and backlight. This one, output, and it's gonna indicate 0. Okay, I'm gonna use, oops, this is not what I wanted. There we go. Copy, paste it here. Okay. So what I'm gonna do now is to use the element 0 and element 1, okay, that belongs to this one, okay, to the green one and the red one, okay. So let's go back to the programming. So we need to use the logic comparison, okay, in operator and standard blocks. Logic, we need to use the OR, okay. So in case that we have more than one expansion models, we can use the OR, okay. So in this case, I don't have any other model, so we're going to use a constant, and it uses a boolean to false. Now we're going to compare this. Is this logic is equal to 1, okay. I just added more function block just to give you an idea, okay. Comparison equal, okay, if you want to compare two values, equal to 1 in this case, logic will be true. Then I want to, so if there is any error, this one should be 1. So 1, 2, true is true, and then I need to power or activate the LED green, red, and disactivate the green one. So this one is the green and this is the red one. So I need to activate that. So in order to do that, there is a function block called move. So we need to go to a standard and use move. Take care of this one. I move is the different stuff. So move, drag and drop. Okay. And we need to move a value 0, okay, to power off the LEDs, okay. And then I'm gonna copy this, copy, paste here, and then I need to move number 1 to this unit, to this variable. That means on, okay. The 0 means off, the 1 means on, okay, whatever this element is, 0, 1, or 2. And the number 2 is blink, but I'm not going to use that in this case. So now we need to link this behavior with this one. So we can activate the enable like this. Okay, right click and enable, or just like this. Okay, with this tool. Now we need to link this connection. There we go. To here. Okay, so when there is an error, okay, this will be the status. The green will be off and the red one will be on. But now we need to use what happened when the communication is correct. So when the communication is correct, this one, okay, the green one should be on and the red one should be off, 0. So in order to do this, we can use in the logic the not. So this means when this is not 1, it should be 0, okay? And when it's 0, it should be 1 and activate this part. There we go. How do you see it in here? There we go. So let's connect to the PLC. It's different, okay. So let's take a video of this. So as you can see here, oops, there we go. This one. So as you can see, there is no error, okay, and I have the green light. As soon as I disconnect this, maybe I need to change the position. When I disconnect this, there is a red light and you can see the logic in there. Oops. And you can see the logic in there. Okay, this one is true. 0, 1, 0, 1, okay. Now we're gonna put that again here. There we go, and it's activated again. Okay, the same can happen, okay, if we don't use the resistor, the N resistor. See, this is a common mistake. Sometimes we forget to use the resistor in there. Oops, there we go. The communication is back to life. Okay, so this is the way to identify if we have communication to the expansion model. Let me just go back to the presentation in case I do not forget about something. We have seen the configuration here. Now it's your turn to download the application, okay, and check if it's working in your side or not. Okay, so if you have any other question, you can contact us, okay? And this is the email address to contact the technical support team here in UK. See ya.